Hello dear students, a very good morning to all of you. Dear children, today's video is about the Lewis dot structures of some special molecules like NaOH, KCN, CaCO3 and NH4Cl. So I am saying these molecules special because these molecules are having two different types of bonding. They are having electrovalent as well as covalent bond. Okay, so let's start the video. Let's take NaOH first. So in NaOH, as you can see here, that one metal atom is present, and we know about the metal that metal completes their octet by losing their electron. Okay, so we know that sodium has 281, means only one electron in its outermost shell. So in order to complete its octet, it has to donate this electron. Okay, so sodium will do the same. It will donate this electron to OH species, and this OH will take this electron, and we have to represent negative charge because of the acceptation of electron. And from here, as electron gone, so we have to show the positive charge. Okay, now because of this positive and negative charge, both these species will attract with each other and will form electrovalent bond. Okay, so in this way electrovalent bond is present in NaOH. Now what about the covalent bond? So let's see. So in OH species, you can see that OH oxygen contributes 6 electron, hydrogen 1, and we will add one more electron because of the presence of negative charge. So we are having total 8 electrons, right? Now as we have already used 2 electrons, okay, so now remaining electrons are 6. So we will show these 6 electron on oxygen atom as it is more electronegative. Okay, and we will put the negative charge also. So you can see here that oxygen has 6, 7, 8, and hydrogen has completed its duplet like 1, 2. It requires only 2 electrons, so it is having 2 electrons. So in this way covalent bond is present between oxygen and hydrogen atom. So in totality we can say that in this molecule electrovalent as well as covalent bond is present. So this is the first example of this category. Now let's talk about the second, KCN. So again here potassium is has metallic character. So because of this it will lose its electron. It is having only one electron in its outermost shell. Okay, 19, 2, 8, 8, 1. Okay, so let's see. This electron Cn will take, and negative charge will appear here, and here we will show positive charge. Okay, this is the electron which potassium is donating. Okay, now because of this positive and negative, again electrovalent bond will form between these two. Now what about the Cn species? So in Cn, carbon contributes 4, nitrogen 5, and we will add 1 because of negative charge. Now we are having 10 electrons. So we have already used 2 electron here. Okay, so now we are having 8 electrons. So 8 electron we will represent 1, 2, 3, 4, 5, 6, 7, 8. Now octet of carbon is not completed yet. It has only 1, 2, 3, 4 electrons. Okay, so it needs 4 electrons more. So these 4 electron we will take from these lone pairs of electron like this. Now carbon has 6, 7, 8, nitrogen has 6, 7, 8. Okay, means octets of both these atoms completed. So in this way electrovalent and covalent both type of bonds are present in this molecules again. Okay, now let's talk about the CaCO3. So in CaCO3 again calcium has 2 electron in its outermost shell. Okay, 20, so 2, 8, 8, 2. So it will lose these 2 electron, and carbonate will take these electron, and we have to show 2 negative charge here, or here we will show 2 positive. Okay, so because of this positive negative electrovalent bond will form. Okay, now what about the carbonate? So for carbonate, carbon contributes 4, oxygen 3 into 6, and we will add 2 more electrons because of the 2 negative charge. Okay, now we are having 4, 18 and 2 means 24 electrons. Okay, in out of 24, 1 2 3 4 5 6 we have already used. Now we are having 18 only. Okay, so these 18 electron we will represent like this: 1 2 3 4 5 6, 1 2 3 4 5 6, 6 6 6 18. Okay, now let's check the octet. So oxygen, all the oxygen has completed their octets, like they are having 6 7 8, 6 7 8, 6 7 8. Okay, now we'll talk about the carbon. So carbon is having 1 2 3 4 5 6 electrons only. It needs 2 more electrons. So these 2 electrons it will take from oxygen like this. Okay, now it is also having 1 2 3 4 5 6 7 8 electrons. Okay, so octet of all the atoms completed now, and we will show 2 negative charge also. So you can see here covalent bond as well as electrovalent bond is again present here. Okay, now we'll talk about the NH4Cl. So in NH4Cl, remember one thing, that here no metal or non-metal is, no metal is present actually. This is non-metal, but this is not metal. Okay, so here no metal is present, still electrovalent bond will present here because of the presence of positive and a negative charge. Okay, this is a very special case of ionic compound. So here when you draw the Lewis dot structure of ammonium chloride, remember one thing, that it will break into NH4 positive and Cl negative when you dissolve this compound in water. Okay, so when you draw the Lewis dot structure, you will use this form of ammonium chloride. Okay, so let's draw. As nitrogen is contributed 5, 4 into 1 minus 1. Okay, so we are having 8 electrons. So 8 electrons we have already used, 1 2 3 4 5 6 7 8. Okay, so no remaining electrons are left, and we have to put positive charge again as it is having positive charge. Now let's talk about the chlorine. So in general, chlorine atom has 7 electrons, and here negative charge is also present. So octet of complete is already completed, and because of this positive and negative charge, they will combine together by electrovalent bond. Okay, so in this way electrovalent bond is present here, and covalent bond is also present in NH4 positive, means ammonium ion. Okay, so this is how both type of bonding are present in ammonium chloride. So these are the 4 examples. They are different type of examples. So I hope all the examples are clear to you. Thank you.